Okay, today we get to start Unit 10, and we're going to start with this first section, which is looking at similar and congruent triangles. So let's go through these bullet points here. The angles in a triangle should add up to 180 degrees. Now let's look at just triangles that are similar. So if two triangles are similar, then the ratios of their corresponding side lengths are proportional. That's going to be an important one when we get to the examples and we need to determine if the two triangles are similar or not. The second bullet point, if the ratios of the corresponding side lengths of two triangles are equal, then the triangles are similar. So another way of telling us when we have similar triangles. If two pairs of corresponding angles are congruent, then the third pair of angles are also congruent. So if we have two triangles and we know that two of their angles are the same, congruent means that same measurement, then we also know that the third pair of angles must be congruent or the same measurement as well. This is also called angle-angle similarity. So I'm going to write that down just as a shorter way of saying that. If two triangles are similar, then their corresponding angles they're the same measurement, so they are congruent. And then this last bullet point is another one that we're going to be using a lot. If the corresponding angles in two triangles are congruent, then the triangles are similar. Okay, so similar is different from just the triangles being congruent. Congruent triangles means that we have all of the angles are the same, all the corresponding angles are the same measurement, and all the corresponding sides are the same. So if the corresponding sides of two triangles are congruent, then the two triangles are congruent and thus have identical shapes. All corresponding angles are also congruent. So congruent and similar are two different things. And then I'm going to just introduce this symbol for congruent, the equal sign with the little wave up above it. That way we don't have to write congruent each time that we want to use that word. We can use the symbol congruent. So for our first examples, the instructions are asking us if the two triangles are similar, and if they are similar, we need to explain. So when you take a look at number 1, notice the markings inside the triangle. So these little arcs mean that this angle is congruent to this angle. So if it's marked across the angle, that means it's referring to an angle. And then we have one arc across angle A and one arc across angle T. That means angle A is congruent to angle T. Now according to one of these bullet points up here, if we have two pairs of corresponding angles that are congruent, then the third pair would also be congruent. So if we know that two pairs are already marked congruent, we can go ahead and mark the third pair of angles congruent. So I'm going to use 3 arcs across angle C and 3 arcs across angle R, which means angle C is congruent to angle R. So are these two triangles similar? Yes. And we could explain it by talking about how two pairs of angles were congruent, so the third pair of angle is congruent. And then we could also state that using angle-angle similarity. So I'm going to go ahead and put as my explanation angle-angle similarity, because we already knew that two of the corresponding angles were congruent. Alright, let's go over to number 2. Instead of the little arcs, they've given us some angle measurements. Now remember that the first thing we stated was in a triangle all of the angles add up to 180. So the first thing we're going to do is find the missing measurements of the angle. So 36 plus 70 is equal to 106. Then we need to take 180, subtract that 106 to find this missing piece. So let's go ahead and mark the angle N is 74 degrees, and let's find this missing angle measurement, angle C. So add 74 to 32 and subtract that from 180. So angle C is 74 degrees. Now, in order for these two triangles to be similar, their corresponding angles must be the same measurement. Well, I have angle M is 36 and angle B is 32. If even one pair is not the same, then we can go ahead and state no, and we do need to give a reason. The corresponding angles are not congruent. And remember, congruent means they're not the same measure. So corresponding angles are not congruent. Alright, so numbers 1 and 2 dealt with the angle measurements. Now on 3 and 4, notice they give us some measurements, but the measurements are outside the triangle. So this is referring to the side lengths. So if the measurements are outside the triangle, they're talking about the side lengths. In order for these two triangles to be similar, then let's look at this bullet point up here. The ratios of the corresponding side lengths have to be equal. Now, ratio means we're setting up a fraction. So let's go ahead and find our corresponding sides. So 110 is my longest side on this triangle. Longest side on this triangle would be 30. So these are corresponding sides, so let's set up a fraction or a ratio showing the measurements, 110 over 30. Now that has to equal, so we're going to set up three ratios here. That has to equal, let's take my shortest side measure on this triangle is 66, and my shortest side measure on this triangle is 17. And then the last pair of corresponding sides would be 89 compared to 24. So we have set up all three of these ratios. I'm just going to type in the calculator 110 divided by 30. And I'm getting, or we could simplify it even. I'm getting 3.6 with an overbar. Type in 66 divided by 17. And I'm getting 3.88 something. Type in 89 divided by 24, and I'm getting 3.7. Now, all of three of these would need to be the same or equal in order for these triangles to be similar. None of these are the same. So this is kind of our work showing that. And our answer is no, because the ratio of corresponding sides are not equal. So kind of box that. That's part of our answer, this explanation. These ratios are not equal, so these two triangles are not similar. Okay, and then the last one on this page, we have two triangles that share a common vertex right here, and they share some of their side lengths. So I have this small triangle, and then I have this larger triangle that we are going to determine whether or not these are similar. So let's go ahead and set up the ratio of the side lengths. So if I want to find, on my small triangle, if I want to find this side length right here, I do need to do some work. 72 subtract 60 gives us this side length. And then to find this side length, I would take 36, subtract 30. So let's go ahead and put that measurement in. Now we can go ahead and set up our three ratios. And it doesn't matter which one you start with. I'm going to go ahead and start with this 12 right here. So the small triangle 12 corresponds to the entire length of this large triangle, which is 72. And remember, we're setting up 3 ratios. Then we need to go back to the small triangle. So we have this 11 corresponds to this triangle 66, and then our third side of the triangle on the small would be 6. It corresponds to 36. So I just take my calculator out and divide. So 0.16 with the overbar. 11 divided by 66 is 0.16 with the overbar over the 6. And 6 divided by 36 is 0.16 with the overbar over the 6. So all 3 of these are equal. So this answer is a yes, because the ratio of corresponding sides, or the ratios, are equal. So go ahead and get the rest of that explanation copied down, and then we'll take a look at the second side of section 1. So on the second side, they tell us that these triangles are similar, and they want us to find the value of x. So if we know that these triangles are similar, then we also know that the ratio of the corresponding sides has to be equal. So we're going to set up a proportion. So let's go ahead and set up, remember, a proportion is 2 ratios equal to each other. So we're going to have 2 fractions. So this side right here, x minus 1, it corresponds with this side right here on this triangle, x plus 5. So I'm going to set up that ratio. Then I need to go back to this first triangle I started with. We know this side is 2. This side corresponds with this side on the second triangle. So now we have a proportion set up. We're going to go ahead and cross multiply to solve this proportion. So we're going to take 5 times x minus 1 and set that equal to 2 times x plus 5. So I'm putting parentheses around the x minus 1 and the x plus 5 because we need to distribute. So 5x, 5 times negative 1 is negative 5, is equal to 2x plus 10. And then just continue solving this equation. Subtracting 2x from both sides, adding 5 to both sides, and dividing by 3. So now we have the fact that x is equal to 5 for that first problem. Okay, on the second problem, this is another triangle, small triangle and large triangle. So let's go ahead and set up another proportion here. So I'm going to start with this small, remember, a proportion is 2 ratios equal to each other. The small triangle 3 corresponds with the large triangle. We need to find the large triangle. This side would be 3 plus 5. So it corresponds to 8. And then on back to the small triangle again, x plus 2 for this side. And we need to figure out what this large triangle side is. So this entire side here, we have x plus 2 plus 6. So the entire thing would be x plus 8. So go ahead and set that up. Okay, from here let's cross multiply, just like we did on the previous problem. So 3 parentheses x plus 8 is equal to 8 parentheses x plus 2. And distributing, 3x plus 24 equals 8x plus 16. Subtracting 3x from both sides, 24 equals 5x plus 16. Subtract 16 from both sides, 8 equals 5x, and then dividing by 5. So you could leave this as a fraction or as a decimal. I'm going to go ahead and leave it as x is equal to 8/5. And if you wanted to, you could change that to 1.6. Okay, number 7. Let's go down to number 7 and set up a proportion. So I'm going to start with this large triangle side. So I have -3 plus 7x corresponds to 13. So that would be the small triangle's corresponding side. And then we need to go back to the large triangle. This side is 27, and it corresponds to the small triangle's 9. All right, let's cross multiply. So 9 parentheses -3 plus 7x is equal to 27 times 13, 351. Distributing, we get -27 plus 63x equals 351. Add 27 to both sides. 63x is equal to 378, and then divide by 63. So x is equal to 6. All right, number 8. Let's go ahead and set up a proportion. So the x plus 3 corresponds to the 2x minus 8 on the second triangle. So x plus 3 over 2x minus 8 is equal to, back to that first triangle, 5 corresponds to 3. Okay, cross multiplying. Just be careful when you're cross multiplying to make sure that you distribute the 3 to each term and the 5 to each term. So we have 3x plus 9 equals 10x subtract 40. Okay, continuing to solve, I'm going to subtract 3x from both sides and add 40 to both sides. And then my last step, I will divide by 7. So I'm getting that x is equal to 7. All right. The last problems on this section are real-world problems using similar triangles. So we know triangle ABC is similar to triangle DEC. So this is a small triangle within a large triangle. What is the height of the tree? So we're going to go ahead and set up a proportion, just like we did on the ones up above. So let's take the height of this tree, which is x. It corresponds with the height of this person, which is 4. And then back to the large triangle, let's take the entire length, which would be 9 plus 6, or 15. That side corresponds to this side right here, which is 6. Then cross multiply. 6x is equal to 60. Dividing by 6, x is equal to 10. So we know that the tree's height is 10 feet. All right, number 10, Hank needs to determine the distance AB across the lake. So this distance right here. He can't measure the distance directly over the water, so instead he sets up the situation as shown below. What is the distance across the lake? So we are going to use similar triangles. So let's go ahead and set up our proportion. X that we're trying to find corresponds to 412. And then this distance, 1,264, corresponds to this distance, 260. Let's go ahead and cross multiply. So 260x is equal to 520,768 divided by 260 gives us 2002.95 if we rounded to the hundredth. So the distance across the lake would be 2002.95. Looks like we're talking about meters. So put that label there. Okay, the last problem, a 40-foot flagpole. So we have a flagpole that is 40 feet high. It casts a shadow, so I'm going to put the shadow down here. The shadow is 25 feet. Let's go ahead and finish out that triangle. Find the shadow cast by a nearby building. So now we have a building that is 200 feet tall. And we want to know the shadow. So we want to know this distance. So let's draw that triangle. So we have two similar triangles here that we are going to set up a proportion. So the height of the flagpole 40 corresponds to the height of the building, 200. Set that equal to the height of the flagpole shadow, which is 25, over this missing height. Cross multiplying, 40x equals 50,000, and then divided by 40, oops, one extra zero there, 5,000. So divided by 40, x is equal to 125. So 125 feet for our answer on that last one.